Today we're going to be looking at something called quadratic systems, which basically means the point of intersection of a quadratic function and any other function. So for example, the first question from your homework is to solve this system. Now this is a linear quadratic system because the first equation is quadratic and the second is linear. And what this really means is to find the point of intersection of these two graphs. Now, you know many ways to do this. One is to graph these two equations. You could do that using your graphing calculator. And let's rewrite this quadratic in intercept form just to make that a little bit easier. And let's add the line we know how to graph. So you need to find the points of intersection of the line and the parabola. Now, of course, there can be two. You could have a line and a parabola that have one point of intersection, or you could have a line and a parabola that have no points of intersection. Now, how do we determine these? Well, the easiest way probably is to use your graphing calculator if it's paper 2. Just find the POIs. But of course, you can do this algebraically as well. We can use substitution here. Since y is both equal to x squared plus 4x minus 5 and 2x plus 3 at their point of intersection, we know they must be equal. And now this is a quadratic. We put 0 on one side, and we can solve this by factoring. So this is x plus 4 times x minus 2, which means that x equals -4, or x equals 2. But since we're looking for a point of intersection, we also need the corresponding y values. You can plug these x values into either equation. The line is definitely easier. So when x equals -4, y equals 2 times -4 plus 3, which is -5. And when x equals 2, y equals 2 times 2 plus 3, which is 7. So therefore, the points of intersection, which are the solutions to the system of equations, are -4, -5, and 2, 7. But in today's lesson, we're going to be looking at more than just the points of intersection of a line and a quadratic. I could ask you to find the point of intersection of a quadratic with any other function. Let's look at some examples. What if I had, say, y equals x squared minus 1 and y equals the absolute value of x? Now, where do those intersect? Well, remember, you can always graph these out. X squared minus 1 looks like this, and the absolute value of x looks like this. And you can always use your TI Inspire calculator to find these points of intersection. However, if you feel like doing it algebraically, you can once again attempt to solve the system. Remember, the absolute value of x can either be x when x is positive, or negative x when x is negative. So solving for these points of intersection really just means you are solving these two quadratic equations, and you have to make sure that all your solutions work. So you could have up to 4 solutions, but we know only 2 solutions are going to be valid points of intersection. So today's lesson, I want you to try to do this worksheet on your own. Okay, you can always use your calculator to check the paper 1 questions, and I really want you to think about these questions. Thanks.